Everybody, and welcome to the tutorial. In this tutorial we are going to cover the hexadecimal notation, and there are four elements that we are going to go over, which are how does it work, or the basics of the hexadecimal system, how do we convert from decimal to hexadecimal and vice versa, how do we convert from binary to hexadecimal and vice versa, and why do we use the hexadecimal notation, or why do we even need the hexadecimal notation. Now usually we start by explaining this question, but you really need to understand the ins and outs of the hexadecimal notation, and once you do that by covering the first three elements, it will be very easy for you to see why do we use the hexadecimal notation. So let's get to it. So just like we're going to start again by talking about the decimal system, right? The decimal system. So in the decimal system, we do have 10 one-digit numbers, or 10 one-digit numbers, ranging from 0 to 9. And if we want to express numbers that are beyond 9 or that are larger than 9, we use what we agreed to call places or digits or positions. And each of these digits or places or positions, each one of them has a value. We call this first position, we call this first position, this one here, the units position, right? So if we put 2 in here, that will mean 2. In the decimal system, again, this second position has a value of 10 raised to the power of 1, which is the tens position or place. If we put 1 here, so that means this number is 12. And I have explained this in the binary system tutorial. Please go watch it if you want a thorough explanation for that. Now the same thing goes for the hexadecimal, right? Hexadecimal. Now the word hexa here means 6 in Latin, right? So hexadecimal means 16. So just like in the decimal system we've got one-digit symbols to express numbers from 0 to 9, we have 10 one-digit symbols to express numbers from 0 to 9. In the hexadecimal notation, we've got 16 one-digit symbols to express numbers ranging from 0 to 15. Now how do these one-digit symbols look like? For the first 9, they look exactly like in the decimal system. So from 0 to 9, it's exactly the same, right? Now for numbers that are larger than 9, like for 10, 11, 12, 13, 14, and 15, we start using letters. So here, this is hexa, right? And here, this is decimal. Okay? So decimal and hexa. So 1 in hexadecimal is the same as 0 in hexadecimal. It's the same as 0 in decimal. 1 is the same till you get to 9. 10, the equivalent of the hexadecimal is A, B, C, D. That's D, A, B, C, D, E, and F. So what I'm trying to say is, if you want to write 15 in hexadecimal notation, so you write the letter F. If you want to write 13, but in hexadecimal notation, that would be D. Okay. What if you need to write numbers that are larger than 15? Well, the same thing. Just like the positions or the digits that we use in the decimal system, we also have positions or places to use in the hexadecimal system. And any value of these positions, v, right, equals b raised to the power of n minus 1. You should be used to this equation now, where b is the base in this case. The base in the hexadecimal notation is 16. The base in the decimal system is 10. So 16 raised to the power of n. N is the rank of this digit. So this first digit has the value is 16 raised to the power of 1, because first rank, minus 1, that would be 16 raised to 0. So it's got a value or weight of 1. So again, that's why we call this here, sorry, that's why we call this the units. We call this the units position or the units place. The second one, let's use this equation. Okay, so the second position here has the value of, let me drag this up a little bit. The second position here has a value of 16 raised to the power of 2, n equals 2 because it's the second position, minus 1, so equals 16. So this here would be the 16's position, and this here would be the 256 position. How do I know that? Because the value of this place, the value of this place equals 16 raised to the power of 2, which is 3 minus 1, and that would be 256. So again, back to the question, if I wanted to express number 16, I would put 1 here in the 16 position and 0 here in the units position, because the largest one single digit symbol I have is 15. So if I wanted to express a number in the hexadecimal notation that is larger than 15, I put 1 in the 16's position and 0 in the units position. So what I meant to say is, this is how hexa and decimal and decimal. So this is how you write 16 in the hexadecimal notation. If you wanted to write 32, you put 2 in the 16's position and 0 here. So this is how you write 32 in the hexadecimal notation. If you wanted to write 33, this is how you do it. So this is 33. What if you wanted to write 161? Yes, you need to put 10 here in the 16's position and 1 here. So that would be 1 here in the units position and A here. Why? Because A in hexadecimal notation means 10 in decimal notation. So here, right here, this is 161. Okay, so now that I think that we have covered the basics, I guess now we have covered how does it work, or the basics. Now we need to go to the second element on our list, which is now how do we convert from decimal? How do we convert from decimal to hexadecimal? So to convert from decimal to hexadecimal, we are going to follow a 3-steps algorithm. First, we will divide the number by 16, which is the base, and record the remainder. Okay, and then we keep doing this until the quotient remember this, is less than 16. When the quotient is less than 16, we pass the quotient, we pass it, which is the quotient, as the last remainder, and then we are done. Okay? Then our hexadecimal number would be all the remainders from the bottom up. Okay, this might be a little bit confusing, but again, I'm going to give you an example that's going to make life very easy for you. So let's have an example. So let's say that we want to convert number 67. Okay, we want to convert number 67 that's in decimal. We want to convert this to its hexadecimal notation. We'll just follow the simple algorithm. I'm going to write here Q, this is the quotient, and I'm going to write here R, this is the remainder. So the first step is to, okay, divide by 16 and record the remainder. Very good. So 64 divided by 16 equals 4, remainder 3. Why? Because 4 times 16 is 64 indeed. 64 is 16, sorry, times 4. Okay, that would give us 64. So the quotient here is 4 and the remainder is 3. We always pass the quotient. So quotient goes here and then we divide by 16. But remember, we are supposed to do this, to keep doing this process until the quotient is less than 16, which is this case. This is 4 is less than 16. Then we pass it as the last remainder and then we are done. So this will pass as the remainder here. Why? Because it's less than base or less than 16. We are done, and all the remainders from the bottom up, so is our hexadecimal representation. So this is our hexadecimal equivalent of 67, but remember from the bottom up. So 43. This in hexa is the same as 67 in decimal. Okay, that equals 67 in decimal. Very good. So this is how we convert any decimal number to its hexadecimal equivalent. Now, how do we do the opposite? Like, how do we convert from hexadecimal to decimal? Now, that's very easy, just exactly like we did in the binary, converting binary from converting a binary number from binary representation to its decimal equivalent. So what we're going to do is we will convert this back as an example to its decimal equivalent. All you need to do is you add up all the numbers multiplied by the position weight. So remember that we said this is in the hexadecimal notation, this is the units place, and this is the 16ths, right? 16 raised to the power of 1, and this is 256 or 16 raised to the power of 2, right? So we have 4 here and we've got 3 here. So all we need to do is 3 plus 4, right, times 16, because this is the 16th place, times 16. That would be 3 times 64. That would be 67. And this, so decimal, right? Decimal. And that will take us to our the value that we started with. Very good. So I guess we are done with this part. So now we know how to convert from decimal to hexadecimal and vice versa. Now comes the second part, which is converting from binary to hexadecimal and vice versa. So let's say we have this let's say we have this number here. We have this binary number, which is this number. And we want to convert this number to its hexadecimal equivalent. So what we will do is we are going to follow a two-steps algorithm, which is one, split the number, I'm going to call it x, so split the number into groups of 4 and convert to decimal. Convert to decimal. And then converts to binary, to hexadecimal. By the way, guys, there are so many ways to do this, but I think this way is an easy one. So again, it's a two-steps algorithm. First, you split that number into groups of 4, convert it to decimal, and now it's very easy because we have studied before how to convert from decimal to from decimal to hexadecimal in the previous part. So to make it easy for you, just put like a little dot in here, and let's, you know what? Let's copy this number down there. So right here, it's 1101 1011, right? So just put a little dot right here. This is going to make your job easier, and that way you split it into groups of 4, and then put the values over here. 1 2 4 8. 1 2 4 8. Remember, what we are doing is we want to convert this to hexadecimal, and we're going to do this by converting it first to split x into groups of 4, which is what we did. Convert it to decimal first, and then convert it to hexadecimal. So this is 8. So this first group, right, is 8 plus 2, 10. So this is 11 right here. And this here is 8 plus 4, that's 12, plus 1, that's 13. Guys, if you want to know how to convert from binary to decimal, I have done a tutorial on that. Please go watch it. Okay, so we know that 11 in hexadecimal is B, and that 13 is D. How do I know that? From this table right here. From this table. Sorry. Yes. From this table, right? So D is 13 and B is 11. So that's it. You can split it into groups of 4, convert to decimal. On the second part, convert that decimal. It becomes very easy. Each group of 4 convert it from decimal to hexadecimal. So that number right there, which is in binary, which is in decimal, is 1311. That would be DB in hexadecimal, right? Hexadecimal. Okay, now we need to do the opposite, which is how do we convert from hexadecimal to binary? Well, you guessed it right. We are going to do the flip, or the opposite of this algorithm. So to convert from, let's write the two algorithm. I need you to see both. So this is binary to hexadecimal, and just in one step from hexadecimal to binary, we first convert to decimal, and then from binary to and then from decimal to binary. You know what? Let me write it down like this. Yes. and then from decimal to binary. So just 2 steps to convert from hexadecimal to binary. You need first to convert it to decimal and then to binary. Let's convert this back, this dB, into binary. So this is how we do it. Let's drag this up a little bit. Exam question: convert this into binary. Okay, so that would be B would be 11 from the previous table, and D would be 13 from the previous table. And to convert this to binary, 1, 2, 4, 8. Dot 1, 2, 4, 8. So 11 is 8 plus that's 11, because 8 plus 2 plus 1. 13 is 8 plus 4 is 12 plus 1. So here's your number, 11011011. Okay. So now we have covered this part. This is how you, if you want to compare the number. So 1101, 1011, same right here. Okay, so I guess we're done with this part. It's very easy, how to convert from binary to hexadecimal and vice versa. Now very quickly, why do we use this? Why do we use the hexadecimal notation? And there is a reason that I deferred answering this question up until this point in the tutorial. Now, do you see if you have a number like this? Let's say you have a number like this. You see how this number looks like? It's very, for a computer it can understand this, but for a human, what does this mean? It doesn't mean anything, right? So the hexadecimal notation, if you want to convert this to hexadecimal, this is how you do it, right? Split it into groups of 4, and then this number here is 8. We said that's 11, so that would be B, correct? And this is here is 13, so that would be D. And oh, I meant to this point, I meant to put this point here. Sorry. Okay. I don't want to confuse anyone. Okay. So, and this 4 here, this is 8 plus 1, so that's 9. So that would be 9. And this here, that's 8 plus 2, that's 11 again, so that's B. So my point is, if you see a number like this, B9, D, B, this makes some more sense, a lot more sense than this number, especially if you don't have the dots. And this is one of the reasons why humans prefer sometimes to use hexadecimal notation, because it's easier to remember or easier to work with than a very long bit pattern that doesn't really mean anything. Now, one more thing before we end this tutorial. Sometimes when you are converting, if I ask you to convert this number here, right, to hexadecimal, right, let's say this. So how are you going to split this into groups of 4? Because it's not 8, it's not multiple of 4s. What you do is you put a dot here, okay, and you complement this with 2 zeros right here. Yeah, that's how you do it. So you can still say, okay, this is 1, 2, 4, this is 5 here, and this here is 3, correct? So in hexadecimal, this is 35, and hexa, right? This is not decimal. You write it like this, 16, meaning this 35 is a hexadecimal number, because 35 is legitimately, somebody could read it as a decimal number. So again, if you got a number that is not multiples of 4, you want to convert it, you just add zeros to make it 8. Thank you guys for watching, and I hope you enjoyed this tutorial, and I'll see you in the next one.